Hey geometry class, we are going to be looking at section 8.4, and what this is all about are we're going to be looking at properties of rhombuses, squares, and rectangles, and we're going to be using those properties to, just like we did in parallelograms, solve for certain x values or just determine what kind of shape it is that we have, like classifying our quadrilaterals into rhombuses, squares, or rectangles. So let's take a look at their properties. In your book, all of this that you see on this page right here is written throughout the section, but here it is all in just a nutshell. The definition of a rhombus is what you see right underneath it. A quadrilateral is a rhombus if and only if it has four congruent sides. So basically, a rhombus is a four-sided shape that has four congruent sides. And there you go. That's a rhombus. Rectangle. A quadrilateral is a rectangle if and only if it has four right angles. So a four-sided shape with four right angles. And then a square is a combination of a rhombus and a rectangle. So a quadrilateral is a square if and only if it has a rhombus, it is a rhombus and a rectangle. Or you could say if and only if it has four congruent sides and four right angles. And that's what you see pictured here. Same goes with the rectangle and the rhombus. But there are also other properties for each of these shapes here. So let's look at them. All three of these, as you can see here, here, and here, all three of these quadrilaterals have all the same properties as a parallelogram. So a rhombus, rectangle, and a square are parallelograms, okay? Because a rhombus, uh, both or opposite sides are congruent. As you can see, these opposite sides are congruent, these opposite sides are congruent. Well, you can go through the whole list of properties of parallelograms and see that all three of these meet the criteria of a parallelogram. But another property of just the rhombus here, it says diagonals are perpendicular to each other. Well, that is true. If you draw in your diagonals where they intersect, it's going to be perpendicular, meaning they cross each other at a right angle. And then just like in parallelograms, the diagonals bisect, well, they don't bisect each other, but they bisect angles. That's not what a parallelogram has, but the diagonals, they do bisect the angles, meaning this right here. If I were to draw in, let's see if I can do it, sort of. Draw on that shape here. Close enough. Right here, it's saying the diagonals bisect. So this diagonal drawn in right here, it means this angle right here is congruent to this one over here. Same on this one. Even though it doesn't look like it, it really is. I just can't draw exact segments on this thing. Okay, these two angles are congruent. And then over here, I'm not even going to try to do that one. But you can see that in a rhombus, all of these are our properties. Now, the rectangle has a couple other properties that we haven't looked at. All angles are congruent. Well, we should know that because they're all four right angles. And then diagonals are congruent, meaning these are the diagonals that can be drawn in. I'm going to try this. These two segments that I just drew are equal to each other. Okay. And then a square, just like its definition, it's just a combination of the rhombus and the rectangle. So a square has all the properties of parallelograms, rhombuses, and rectangles. Okay, so that is it on properties and definitions of these shapes. So let's use them in some examples. Okay, so in this example one, we are asked to use properties of special quadrilaterals to do this. It says for any rhombus ABCD, decide whether the statement is always, sometimes, or never true. Draw a sketch and explain your reasoning. So we're going to draw a sketch to help us in explaining. That's what this last statement means. But first, let's just determine whether this is sometimes, always, or never true. It says AB is greater than BC. Well, if we were to go ahead, let's draw in a rhombus. So remember, rhombuses have 4 congruent sides. That was terrible. We're going to call that congruent. So this side, all 4 of these are congruent to each other. And let's label these. That's my A, B, C, D. So whenever you're labeling any shape that you're given, A, B, C, D, go in order, like in a clockwise or counterclockwise motion. Doesn't matter which, just as long as you go in that order. So A, B, C, D, or this way, A, B, C, D. Either way will work. So we have rhombus ABCD here drawn, and it is saying this right here is our statement. Is that always, sometimes, or never true? And AB here and BC, they're never going to be greater than or less than each other. They're always going to be equal to each other. So our explanation is A, AB is equal to BC, not greater than. Okay, so this statement here is never true. Now let's move on to part B here. I'm going to go ahead, just like this one here, I drew in our shape. Let's draw in another rhombus that is ABCD. Okay, you know this is a rhombus because it's being stated that all sides are congruent. A, B, C, D. Now, we are asked this question here, that the measurement of angle A is greater than the measurement of angle B. Well, in this case right here, that looks to be true. We did draw that A measurement of A is greater than the measurement of B here. But what if we had this? Remembering that squares are also rhombuses. If we drew it in this way, we would see that our rhombus, or square here, that is ABCD, it has 4 congruent sides, but also, since a rhombus or a square is a rhombus, these all are equal to each other. They're all 4 right angles. So what we get for this statement here, that ABCD, the measurement of angle A, is greater than the measurement of angle B, that's only sometimes true. So say sometimes true. And that's how we go through our explanation using our drawings here and explaining our reasoning of how we know that this is only sometimes true. Now, in your homework, we will have a section where we're classifying these special quadrilaterals. We have 2 more special quadrilaterals to study after this section. We're going to be looking at trapezoids and kites. But this section focuses only on these 3, rhombuses, squares, and rectangles. So to classify the quadrilaterals that we're looking at in this section, it's either going to be a rhombus, square, or rectangle. And looking at this one, it's asking us that question. Classify the special quadrilateral and then explain your reasoning. And for this one here, what I would say is, well, we know that these 2 sides are parallel to each other, and these 2 sides are parallel to each other. We at least know that this right here is a parallelogram. But then we have a right angle here and a right angle here? Well, we can show because of these parallel lines, say these two parallel lines right here, and this transversal going through it, we can figure out or prove that these two angles over here are also right angles, since these two over here are right angles with this parallel line going through it. Okay, since this line is parallel to this one over here, and these two are parallel, and these angles are right angles, then these are right angles too. Okay, so what we have here is a rectangle because these two sides are not congruent, so therefore we do not have a square or a rhombus. And so there's our reasoning. We have a rectangle because we have opposite sides are congruent, and we have 4 right angles. So rectangle. And the reasoning behind it is because all 4 angles are right angles. And that's the definition of a square. Now, on a test or a quiz about these specific quadrilaterals that we are looking at in this section, I do expect you to know all the properties that we have looked at by heart, and so be able to answer something like this right here. So this one, it says, sketch a rhombus ABCD, list everything you know about it, which means what is the definition and what are all the properties that we know. And we can, what I'm going to do in this, so just kind of be a time saver, is just go back to here. So rhombus, we should know this right here, that it is a quadrilateral with 4 congruent sides. It is a parallelogram, and it meets all the properties of a parallelogram. And then the diagonals are perpendicular, and the diagonals bisect the angles. And there you go. That's what you need to list out. And I actually do want you to write this down on example 3. Just rewrite it, those properties, down right here for me, so I know you actually listened to this. So do that for the example 3. And then the last thing that we're going to do in this lesson is what I want you to do is this lesson quiz all on your own. So finish this up and we will go over all of these problems in class whenever I see you next. So goodbye, everybody.